everyone. Thank you for the introduction. So, as already been told, my name is Jakob-Leveraging, and I'm holding a presentation on leveraging classification knowledge for improved data accessibility in digital construction. So, when we talk about digitization in construction, the whole industry basically relies on highly structured data formats like IFC. And there are some key issues introduced with that. So, we have a high complexity due to detailed and multidimensional tasks. The complexity limits data accessibility, hindering stakeholders from understanding and effectively utilizing the information. And stakeholders from various backgrounds basically struggle with complex data formats impeding the effective adoption and use of digital models. So, the current state, just a quick catch-up. What are classification systems so that we are on the same track? So, classifications basically ensure a unified understanding of terms, promoting consistent organization and communication across domains and countries. And these are applied across various disciplines in the construction industry. Three main aspects that come with classification systems. At first, we have the information retrieval. So it basically simplifies finding and accessing relevant data. Second, we have the communication, which basically enhances clarity and consistency in information exchange. And of course, we have a standardization, which basically promotes uniformity. And for example, we have the German DIN 276, where we have an external wall, which is basically classified into load-bearing and non-load-bearing. So, classifications in digital models. When we talk about classifications in digital models, we basically have to talk about the IFC schema. And the IFC schema already includes a lot of classifications, but they are not really widely used in practice yet. And currently only a few tools like Solibri and BIM-Collab use them. And the problem with that is basically that different users encounter a lot of problems, and because they do not want to delve deeper into the subject. And the challenge that we are facing regarding this project is to make it easier for all stakeholders to work with IFC without having to deal too much with the complexity of the IFC schema. And of course, in practice, we have different methods of classification. And the first one is pretty well known, and probably most of you know this already. This is the attribute-based classification, where we basically manually add attributes to components and classify them. This is also shown here on the right side. Just a quick screenshot from Nemetschek Alplan, where we have a classification and basically assigning them manually. So the advantages are on hand. Of course, this is very flexible, and this can be tailored to a specific project need. And this is very intuitive and based on observable and measurable characteristics. But we also face a lot of challenges regarding that. We have a lot of manual effort because significant time and effort required for manual classification. This is extremely error-prone with high potential for inconsistencies and mistakes. And of course, there is a need for consistency, which basically requires all stakeholders to have a coherent understanding of the classification system to maintain the said consistency. So, again, there is an example called BIM Deutschland, which are basically guidelines that already recommend adding attributes for classification manually according to the set DIN 276. And on the other side, apart from the manual classification, we have the rule-based classification, where users can basically define static rules and characteristics because it can determine these different components and cause it to be classified accordingly. I think the advantages are on hand. So it's very consistent and efficient, and it reduces manual effort. But we also face, again, a lot of challenges like limited flexibility in adapting to varying project needs. And of course, it's a complex management because rule logic can become complex and very cumbersome. And of course, we have a lack of formalization. So an example I already told is that Solibri Office and BIM-Collab Zoom already use these kinds of predefined rules and smart views for classification. And this is where our proposed solution comes in mind, that we use an already existing standard, IDS, to store this classification. So just a quick catch-up. IDS is in general a standard for machine and human-readable description of information requirements, and it basically supplements the existing model view definitions concept, and it specifies the alphanumeric information content of models, ensuring a detailed and precise data representation. So how to use it? Basically, you can use IDS to standardize and streamline product data exchange in the AECO industry. The IDS standard, and this is a big thing, is from buildingSMART, and it optimizes information exchange, and it basically combines IDF with data dictionary servers like the BSDD. And the IDS standard ensures accurate and up-to-date data through standardized terminology and data structures. So just a quick example how it works. So this is just a very small screenshot of an IDS scheme. And we're basically asking, we are seeing the pattern IFC covering, and we are asking which components should be fulfill which requirements. And this is basically what we see down here: property, property set, pset, covering common, name, flammability rating. So what a user basically sees is that all elements of the IFC covering class that have the predefined type membrane should have a flammability rating property in the pset covering common. So the idea is, can this mechanism also be used for the formal description of classification rules? And all objects of type IFC covering that have membrane as their predefined type should also be assigned to the ceiling classification. So another example, how it should look like. So again, which components should be classified to which classifications. And there we see the classifications already taking place with the URI from the buildings BSDD with different values and different systems. So the benefits of the proposed solution are on hand. We have a highly reduction of manual work because it automates classification using existing information. We are basically speaking a common language because it creates a standardized format for classification logic and facilitating easier management and sharing. And of course, we have an enhanced collaboration, which basically provides a common ground for stakeholders, promoting better understanding and cooperation. So let me demonstrate that really quick to you how it would look like in practice. So we built basically this kind of application. We can load in this application any kind of IFC model. We've taken the well-known Solipri building IFC, and we can use now basically an IDS, for example, the test IDS, to do this kind of classification. This takes a little bit of time, but after the IDS is loaded, we can basically see that the classification takes place for this simple classification. And we see, for example, wall, and this is already shown in this kind of application, the different windows, beams. Beams are not available in columns. So let's take another use case. For example, we could take the IDS classification, and there are now classifications according to DIN 276, and as well, for example, classifications regarding the BSDD. So there we have the different classifications regarding DIN 276, and for example, like links to the BSDD with Netherlands classification. So this is just a very small and very broad test case. And this is basically the result that we are facing. So we can basically see the different kinds of classification, and we have these different kinds of colors, and this is also classified according to the DIN 276 with these different classifications. The important thing about this is that the results of the classification can be stored in the IFC itself and as an IFC reference item. So, in conclusion, basically IDS formalizes classification knowledge very effectively, and it enhances collaboration and efficiency in digital construction, and it facilitates intuitive interaction with complex data. And as seen before, it is already demonstrated feasibly through successful test cases, but of course there are a lot of limitations that are introduced with that. So the initial focus in this test case was on the DIN 276, and the very big issue is the dependence on accurate model content. And of course, beforehand, we have a very high manual effort for extracting the classification knowledge. And again, we have a limited market penetration of the MBD XML standard. So future directions could be, for example, automatic extraction of classification logic using AI, and use the classification logic for model validation, and of course, semantic enrichment of models and community-driven methodology refinement. Thank you very much for your attention.